Hello dear students, example number 4. This is example number 4. Charge conducting sphere. Okay, we have a charge conducting sphere. The charge is distributed on the surface. So the charge is distributed on the surface. So let me explain this. For example, we have a charge conducting sphere and the radii of the sphere is r naught, and the charge is distributed on the surface. Charge is distributed on the surface. This is conducting sphere, mean it can conduct charge. Okay, so charge is distributed on the surface and we have to find the potential outside the sphere. So let us take a point, any point, arbitrary point that is outside the sphere. Let say this is r b, this is point b point, so the distance is rb. So this point is at the distance rb from the sphere. Okay, from the sphere. Let me redraw this figure, because suppose this is r naught original and this is rb, this distance is rb, and we have to find a potential for outside the sphere. R is greater than r naught, mean the outside the sphere. Outside, r is equal to r naught, mean at the surface, and r is less than r, mean within the surface, inside the surface. So I write again, I solve for a, r is greater than r naught, mean outside the sphere. So we need to find the potential outside the sphere. Okay, so in order to find the potential outside the sphere, we use formula of potential gradient, that is del V is equal to minus E dot dl. We use this equation, del V is equal to minus in line integral E dot dl. So RA is into RB. Okay, now we put the intensity formula. E is equal to, we know that the intensity E is equal to k over r square, or 1 over 4 pi epsilon naught into k over. So if we put in value of E, so we get 1 over 4 pi epsilon naught k over r square. So I solve separately. E is equal to integral 1 over 4 pi epsilon naught q over r square into dot dl. Instead of dl we can write dr, because the distance is dr, no need to write dl, so we can write dr. So the constant terms to be taken outside, 1 over 4 pi epsilon naught q and 1 over integral 1 over r square into dr. So first I solve in line integral of 1 over r square. So the line integral of 1 over r square is equal to, I solve separately. So r square, we can solve is r minus 2 into dr. We can apply the power formula, rule, simple power rule. Minus 2 plus 1 over minus 2 plus 1. We know that the power rule is add the power by 1 and subtract the same power. R minus 2 plus 1 over minus 2 plus 1. So it gives us r inverse over r minus 1. That will give us minus 1 over r. So the line integral is minus 1 over r. So integral is minus 1 over r. So we replace this integral with the minus 1 over r. So we are left with the potential del V is equal to, so the del V is equal to 1 over 4 pi epsilon naught, so that the integral is minus 1 over r. So the lower potential R A, upper potential R B. Now we solve del V is equal to 1 over 4 pi epsilon naught minus 1 over r. So we can put, so as we know that the high, so first we put high value and then put low value. So as we know that this negative also is, there is negative sign, minus E dot dl. So this negative will be cancelled. So this negative and negative will be cancelled. So we are left with the plus sign. So instead we can write plus sign. So high potential, upper limit RB, we put first upper limit RB minus lower limit RA. So RB minus RA. So del V is equal to 1 over 4 pi epsilon naught 1 over RB minus 1 over RA. So if we take B point, at infinity, so that the 1 over RB mean 1 over infinity, which becomes 0. So the now we have value potential del V is equal to 1 over 4 pi epsilon naught 1 over RA. So this is the formula for so 1 minute, negative sign 1 over b RB minus 1 over RA. So that RB approaches to infinity. So if it becomes, so we have a formula R becomes infinity, 1 over RB, VB becomes 0. So we this term becomes 0. So we are left with the VB minus VA, that is equal to 1 over 4 pi epsilon naught Q over R, for R is greater than R naught. So V is equal to, this is VB minus VA, VB minus VA, VB minus VA, that is equal to 1 over 4 pi epsilon naught 1 over RA, 1 over RA, 1 over RA, negative signs, because RB becomes 0, 0 minus, so this is negative. So because VB becomes 0, potential also becomes 0 at point infinity. So VB becomes 0, so minus VA is equal to minus 1 over 4 pi epsilon naught 1 over RA. So we are left with the 1 over RA. Now negative will cancel, so only potential V is equal to 1 over 4 pi epsilon naught, sorry, here Q, we can write Q over R. So this is formula for potential outside the shell. Okay, now so this is formula V is equal to 1 over 4 pi epsilon naught Q over R. Now we put inside, for the inside. Now we solve for the inside. So in order to find the inside, we use the approach as R. So we use only inside, as we know that not inside, we solve for B part. R is equal to R naught at the surface. At the surface, R is equal to R naught mean at the surface. We just put R instead of R, we put R naught. So we have we replace R with the R naught. Replace R with R naught. So this will give us the potential at the surface. So the potential at the surface is also equal to 1 over 4 pi epsilon naught Q over R naught. Okay, so for the inside, next C part, for the inside, R is less than R naught. So for the surface inside, as we know that the inside electric field intensity E is equal to 0. Because why it is electric field intensity is 0? Because charge is distributed on the surface. When the charge is distributed on the surface, so inside no charge. So if inside no charge, so the electric field, according to Gauss's law, the electric field intensity is 0 inside. So the intensity is 0 inside when the intensity is 0. So if we apply del V is equal to minus E dot dl or dr, so E becomes 0, so E dot dl, so del V becomes 0. So del V becomes 0 mean that there is no change of potential inside, mean the potential at the surface is equal to potential inside, no change of potential inside, no change of potential inside. So inside potential will remain same, that is at the surface. The potential at the surface is also potential at the inside, that is equal to V is equal to K or 1 over 4 pi epsilon naught Q over R naught. So in other words, so if I summarize this one, so that I can say that, if I summarize this one, so if we have a sphere, so this is the surface from center to outer line, the surface radius is R naught. So the charges are distributed on the surface. So charges distributed on the surface, so that not outside, it's on the surface. Sorry, 1 minute. Charges are distributed on the surface. So if charges are distributed on the surface, the potential outside the sphere is V is equal to 1 over 4 pi epsilon naught Q over R distance, at the distance R, and the potential at the surface is, the potential at the surface is equal to V is equal to 1 over 4 pi epsilon naught Q over R naught. At the surface, the distance radii is R naught, so the potential, and for the potential inside at the any point at the inside, so inside is also the potential, that is equal to 1 over 4 pi epsilon naught Q over R naught. The same potential, the potential does not change throughout, so that the inside the same potential as the potential outside, at the potential as